Welcome to Intro to Business SQL. My name is Ken Sanders. And in this course, hopefully we're going to teach you how to write SQL to answer business questions. Course objectives. First, we want to provide a fundamental understanding of databases and tables. Learn how to write simple SQL statements to retrieve and manipulate data. Learn the structured dimensional process flow. And prepare you for more advanced SQL methodologies. A little bit about me again, I'm Ken Sanders, bachelor's MIS from the University of Oklahoma. Worked a majority of my career in retail in a big data environment. I've supported all the different functional areas of a retail organization, marketing, merchandising, operations, pricing, finance. To me, it's all data. And hobbies include long walks on the beach, candlelit dinners, my attempt at a joke. Okay, so preferred requirements, a basic understanding of Excel concepts, rows, columns, summing, minning, maxing, averages, pivot tables, VLOOKUPs, because a lot of these relate to what we're going to actually do with SQL. Okay, let's get started. Overview of tables and databases. So what is a table? A table is a collection of data stored in rows and columns, very similar to an Excel spreadsheet. And this would be an example of a table with store descriptions in it. If you look at this, it looks just like an Excel spreadsheet. And in fact, it really is. That's all that a table is an Excel spreadsheet. Again, we have rows and columns. If we look at a row, you're going to have different data elements going across the row from right to left. In this example, store number, which the number really has no meaning, it's just an assignment to that physical store. But then you go from right to left, from left to right, and you have all the different attributes surrounding that store. And in this case, store number would be the index of this table or the index of this data. And just remember that going forward, we're going to talk about indexes or indices, whatever, a lot. Again, we have a table being a collection of rows and columns of data. And columns contain like data elements, where if you looked across a row is going to have different data elements. If you look down a column, it should be the same type of data. For this example, square feet, all is numerical data, right? That describes the square feet of a store. And so now we're going to talk about the different types of tables. For the most part, and there's probably other different types of tables. There are 4 types of tables that I've run across in my experience. We have attribute tables, and that store description table would be an example of an attribute table. You have an index, which is normally a number. Then you have a lot of attributes about that describe that index. Item number could be an attribute table or some type of item description table where you would have an item number or UPC number, and then all the fields that actually describe that item number: size, color, weight, supplier. And normally attribute tables are representations of physical or abstract entities. And these 4 basic entities in retail are the who, so a customer. You could have a customer attribute table that would have the customer ID, and you would have their birthday, maybe some demographic information, and other information that actually describes the customer. You'd have the what, which is the product attribute table, right? So you'd have a product number or UPC number, and then all the attributes about that item, right? A when, so when would be one of those abstract entities. So a date could have attributes. What quarter is it in? What month it is in? What day of the week it is, right? So that would be another attribute table. And where, so location, stores, warehouses, those would have a warehouse ID or store ID or location ID, and then they maybe would have the city, state, zip, how big it is, right? So those are just examples of the 4 different types of attribute tables you will see in a retail environment. Metric tables, we already talked about attribute tables. The next type of table is that we're going to talk about are metric tables. These contain measures, right? So the index of a metric table is probably going to be made up of more than 1 column, and I'll describe that. So say, for instance, if we had a metric table that had a metric, what do we have an example? On hands, which is inventory. Store, item number, and date would actually make up the index of that table. As before, with the attribute table, you had one column, item number, or store number, or date. Those attribute tables have just one column indexes normally. But for our metrics table, we have store number, item number, and date, and you could have on hands. On hands would be the metric, right? You can have sales, you can have shipments or whatever. Those are metrics. And again, normally for a metric table, you're going to have more than one column that actually make up the index for that table. And again, here are some of the metrics that you would have in metric tables: sales, units sold, inventory, receipts, etc. So we'll talk about transaction and code tables later. And just to pause for a little bit, I want to make a distinction between structured and unstructured data. For the purpose of this course, we're looking at structured data. Again, data that is structured in rows and columns. The other type of data that's out there is unstructured data, and this would be something like survey responses, or maybe something you would type in a browser and get a bunch of results for. That's unstructured data, and that's not what we're going over for this course. More about indexes. An index can consist of a single column or a group of columns that identify a unique row of data. Again, we talked about the attribute table index, normally made up of one column. We have a metric table index, store, item, date would make up a index for its sales table. Now it's time for a quiz. A table consists of rows and columns. Just like an Excel spreadsheet, that's what a table is. From the above, which contains like data elements? That would be columns. Everything in the column should be a like data element. You should have, if it's a numeric column, you should only have numeric values. If it's a text column, you should only have text values. If it's a date column, you should only have date values. What are the 4 types of tables? Attribute, metric, transaction, and code. Again, we'll talk about transaction and code tables later. And blank identifies a unique row of data. What identifies a unique row of data? An index. What are the 2 types of indexes that we've talked about so far? Attribute and metric indexes. For the code tables, they're normally just going to have a 1 column index, and for transaction tables, you'll have more than 1 column that could make up an index as well. Okay, which type of index usually consists of 1 or more columns? And I just kind of gave that answer away. That is a metric table. Okay, so now we know what a table is. Table is data structured in rows and columns. So now what is a database? A database is a collection of tables, of these 4 different types of tables. And just like an Excel workbook has different tabs with different worksheets, a database contains tables. So a workbook contains worksheets and a database contains tables. Again, this is just a further illustration of that. A database, workbook, table, Excel spreadsheet. Just one word, I guess, just to set a best practice, and it's common sense. Tables and database should be named to describe what they contain. So you wouldn't have a sales table that had inventory in it, or you wouldn't want to name it table S12. You would want to name it store sales. Okay, so we know we have tables, and tables exist within a database. Now, when tables in a database are related through common columns, the database is said to be relational. These tables can be related directly or indirectly, and this is an example with a run row table. This is our sales metric table. Again, we have store number, item number, and sales date, which identify a point in time which make up the index, right? So we have sales and quantity. So we have a date attribute table that's related to the sales metrics table, and they're connected on sales date. We have a store number that's in the metric table, right? And it's connected on store number. And you see we have a store attribute table. And we have an item number or item attribute table that's connected to the metrics table through item number. And if you look, all of these tables are related directly or indirectly. And so you might ask, okay, we have all these tables. Why not just put all the information into one table? So for the sales metrics table, well, why don't we just add city, state, zip, and square feet to that table? And this is why. In the early days of computing, storage space was at a premium. We didn't have a lot of space to store data. By having attributes included in metric tables, right, those descriptions included in those tables, you would greatly increase the amount of space needed to store the data. Okay, and so this is an example. So this would be a metric table where we've added the city and state attributes to every row. You can see how large this would make the table if this was repeated, because normally your metric tables are pretty big, right? And so instead of having those included in the actual table, we remove them. And that's part of the process of normalization, is to take descriptive columns out of metric type tables. And you can do something similar to a VLOOKUP in Excel. Later, you would pull your sales data and you would VLOOKUP in the cities and the state or whatever descriptive columns you need. Again, this is part of the normalization process, and tables that actually have attributes listed are said to be denormalized or flat tables. Okay, so just a quick review quiz. A table is equivalent to an Excel workbook. Is that true or false? A table is equivalent to an Excel workbook. That's false. And a table is equivalent to an Excel spreadsheet. Databases contain spreadsheets. False. Databases contain tables. Even though tables are very similar to spreadsheets, for the terminology, tables exist in a database. A metric table that contains descriptions is normalized. False, it's not. Okay. So that's it. That's just a quick overview. Up next, we're going to talk about database systems. And if don't forget to like and comment if you found this useful, and if you want to donate, I would humbly accept your donations. So thank you until the next course.